È mio piacere e onore introdurre adesso il professor Günther Beckli, paleontologo ed entomologo tedesco, autorità riconosciuta e stimata nel campo delle scienze della vita del passato geologico remoto. Già curatore della sezione sui fossili del Museo Statale di Storia Naturale di Stoccarda, a lui si deve la descrizione di un nuovo ordine di insetti fossili e in suo onore sono state nominate diverse unità tassonomiche nella classificazione scientifica degli esseri viventi. Il professor Beckli è Senior Fellow al Discovery Institute di Seattle e ci spiegherà i tempi lunghi dell'evoluzione, i tempi lunghi richiesti dall'evoluzione, fornendo nuovi argomenti di critica all'ipotesi neodarwinista. Professor Beckli, the floor is yours.
So, dear ladies and gentlemen, now other wonders, and we'll see some wonders of the fossil record and of genetics. So there is a problem for Darwinism, and the problem is called the waiting time problem. And this problem arises from uniting two fields of science that are usually considered to be big support for Darwinism. One field is the fossil record, paleontology. And what the fossil record establishes is deep time, millions of years, change over time, also intermediate fossils, maybe common descent. So it seems to establish macroevolution. And on the other hand, we have the field of so-called population genetics. Think about bacteria in a petri dish where you can observe how drug resistance develops and spreads in the population. This seems to establish microevolution. And then the claim is, if you extrapolate this observed microevolution over millions of years, then you have the full explanation of the history of life of macroevolution. But actually, if we really combine these two fields, a big problem arises. And the problem is that the windows of time that are established by the fossil record for certain transitions, for changes in the history of life, they are orders of magnitude too short to accommodate the necessary genetic changes. So the changes that are required to transform these organisms. And you need these changes to occur in a population. This requires a certain waiting time. And these changes have to spread in a population. So we need some background to really understand this problem. So one background is these windows of time, and we today have a much better fossil record than Charles Darwin had. And we can see that certain changes in the history of life, for example, from dinosaurs with hair-like structures to other dinosaurs and birds with real feathers, that this took a certain amount of time and not longer. So in this case, for example, we know it's a window of time of 1 to 7 million years. So this is one point of data that we require. Now the other thing is that we know from empirical data, from empirical observation, that some changes in the history of life required so-called coordinated mutations. This means if you have two or more mutations where each mutation doesn't have an advantage, doesn't have a negative value, it's neutral, it is blind to selection because it doesn't have an advantage. But only when they come together, then they have this advantage and selection can kick in. This phenomenon is called coordinated mutations. And now the problem arises by the following few points. We know that evolution is supposed to proceed by random mutation and natural selection. We also know that selection can only work on mutations that either have a negative or a positive adaptive value, so that they can be selected for or against. And we know that at least some adaptive changes require so-called coordinated mutations. And so we have two time constraints, this time for these mutations to arise in a population and the time constraint for these mutations to spread. Because arising of such a mutation is not enough. The organism that has the mutation could be eaten by a predator, or its offspring could die out. So to spread, something more has to happen than just occurring one mutation in the population. So does the history of life supply sufficient time for this to happen? And this whole thing creates a dilemma because we can play with different parameters. So let's look at population size, for example. Of course, when the population is bigger, then more stuff in terms of mutations can go on. So the time you have to wait for a certain mutation to appear is shorter. But on the same time, when you have a bigger population, it takes much longer for such a mutation to spread over the whole population. And if it doesn't spread, then it cannot change the species, the body plan of the species to something new. So, large population has a positive effect and a negative effect. What about if we take a small population? If we take a small population, then a mutation can spread much faster, but on the other hand, we have much fewer possibilities to play and to get mutations. So the waiting time to get the mutation gets much longer. So that's a dilemma where there is no easy way out. Whatever you change, you get a problem that keeps this problem alive. And maybe if you think of sexual reproduction, where you have a male and a female lineage which combines, you think maybe recombination could help. You could have different neutral mutations in a population and they might combine by sexual reproduction. But this was actually studied, and there is a paper by Christiansen et al. From already 1998, and they studied mathematically what is the effect of recombination, and it showed the effect is small compared to the other parameters like population size, for example. So recombination doesn't help us to solve this problem. And the interesting thing with this problem is that we can really do the math. This is not something where we have to think about fancy storytelling. There is a toolkit in population genetics, which is a mathematical toolkit, where you have formulas, where you can put numbers into, and you can run the math and look what results do you get. And you need only a few parameters. You need the mutation rate. The mutation rate is known in many different organisms by experimental data. You need an estimate of the effective population size. This population size can be also reasonably be estimated. So for example, if you would look at whale evolution, you know the population size of an ancestral whale certainly was not as big as in bacteria. Probably it was not as small as in giant pandas, so somewhere in between, and you can look at modern flora and fauna to make a reasonable estimate. And then you need generation turnover time. How long does a generation take to produce another generation? And this again, you can make a reasonable estimate. In whales, the generation time is not as short in bacteria, so it's some years. And you can again compare with modern flora and fauna to make a reasonable range of possible values this could have. And this problem was discovered by Michael Behe. We already heard of him, one of the pioneers of intelligent design theory, in an article with a physicist called David Snoke in 2004, and then later expanded in his book, his second book, The Edge of Evolution, published in 2007. And what he showed is that these waiting times are prohibitive for Darwinian evolution. It simply can't work mathematically. And what he did, different to some people who later studied this problem, is not just making a mathematical simulation or a kind of model assumption. He looked at empirical data from malaria. And in malaria, you have always, when a new medicament is introduced into the system, after some years you get resistance, drug resistance. And this drug resistance, in the case of chloroquine, which is one of the drugs used against malaria, took several decades. And when they looked into the mechanism of the resistance, they found out it took coordinated mutations to get it. And what he found is the following. If you take this time it took for this drug resistance with one coordinated mutation to develop, and you would transfer the numbers of the population size of malaria compared, let's say, to humans, which is of course much smaller, especially if you look at in an ancestral population of ancient hominins in East Africa some million years ago. It was probably just some 10,000 specimens. Malaria has billions and billions and trillions of individuals. So population size is much smaller in humans. Generation times is much longer in humans. It's not in the range of minutes, or it's in the range of 15 or 20 years. So what he arrived is just by transferring these empirical data is at a waiting time, if humans would have to develop a single coordinated mutation, is 10 to the 15 years. That's longer than the existence of the universe. That could be a problem. So of course in humans we have good data from the fossil record. If we just grant the standard interpretation of these fossils, that the human lineage separated from the chimp lineage about 6 to 7 million years ago. That is the available window of time. And now there were two mainstream evolutionists, and they tried to refute Behe and show that he's totally wrong. And they wrote a paper, and they said it's nonsense, this number of 10 to 15 to the power of 15 years. They made their own calculation, not based on empirical data, but on a model, on a mathematical model. And they arrived at 216 million years and said, yeah, we made it, Behe is refuted, and didn't mention the little problem that 216 million years after their mainstream evolutionist calculation is still far off the available window of time of 6 million years. And we also have to take into account, if we have one value that is won by looking at empirical data, and we have another value that is made by a mathematical model, and each model needs simplifications which can introduce errors. So rather the empirical data are closer to the truth than the mathematical model if they differ. So my claim would be that probably the calculation of Behe is much closer to the real problem than the calculation by these mainstream evolutionists, Durret and Schmidt, but still they confirmed the gravity of the problem. And there was another study in 2015 by Sanford et al., and they also made an estimate for human population, ancestral human population in Eastern Africa of ancient hominids, and estimated population size. This is mainstream knowledge, that's nothing special, of some 10,000 individuals and a generation turnover time of 20 years. And they found in their study, based on a different mathematical model, that even for point mutations, not coordinated mutations, the waiting time would be 1.5 to 15 million years, and for a coordinated mutation, about 85 million years. Now, even if we look just at these point mutations, if we again grant this often said fact that chimp DNA is 95% similar to human DNA, this 5% difference would still translate into millions of different base pairs of mutations that had to arise in the population and spread in the population to make up for these 5% differences. And the time simply is not there in the fossil record, which gives us 6 to 7 million years. So to further look into this thing, we started a collaborative research project at Discovery Institute, where several scientists of different fields collaborated to evaluate this problem further. And so we have molecular biologists like Doug Axe, paleontologists like myself, another molecular biologist like Ann Gauger, a mathematician, Ola Hössjer from Stockholm University, Paul Nelson, who is a philosopher of science, and Richard Sternberg, who is an evolutionary biologist. And in our collaboration, we developed a new mathematical model expanding on existing mathematical models, and these existing mathematical models were not done by Darwin doubters or by intelligent design proponents. This waiting time problem is a well-known fact in mainstream evolutionary biology and genetics, and even very relevant in cancer research. So it's a valid problem that is known and it's uncontroversial. And we used this model and removed some of the obstacles that were there that could be objected. So for example, some of these models didn't allow for back mutations. We changed it into allowing for back mutations. Some people would criticize, well, but there could be different possible solutions. Such a model should allow for different, basically, locks to open the key, different keys to open the lock. So we allowed for different mutations to be successful in a way for a certain solution. And based on this mathematical model, we have published 2 papers in mainstream peer-reviewed literature on this theoretical background. And we have now completed a manuscript which is ready for submission on a specific example, and that is the example of whale origins. And if we look at the fossil record of whales, there is a quite good fossil record, especially from India and Pakistan, going back about 50 million years. And there we can see different forms that are forming this kind of transitional series, where you see a transition from a pig-like animal like Pachycetus to a basically dolphin-like animal like Dorudon. So how much time is available for this transition to happen? If we look at the fossil data, there is sufficient data to know that this is not just an artifact of lacking evidence. We have a lot of finds, meanwhile, and can, with great confidence and statistical support, say that the available window of time for this transition is about 4.5 million years, which is not so much as it may sound. So Richard Sternberg already did some rough calculations some years ago on this problem using the formula by Duret and Schmidt, and again reasonable estimates for the parameters, and he arrived at a waiting time of 43 million years, 10 times the available window of time. So we have only 4.5 million years available, here 10 times the time. Now with our new model and much more sophisticated parameters, so we included the question how many binding sites, what could be the length of the binding sites, and so on. And for reasonable estimates of these parameters, we arrived at waiting times between 144 to 509 million years. So that's absolutely no-go. That is basically a showstopper for the feasibility of Darwinian evolution. And there certainly were many coordinated mutations necessary for making this transformation. And in our paper, we will show, based on EvoDevo data, that this is indeed the case. And just to give you an idea what has to happen to transform such a pig-like animal into a dolphin-like animal, you have to, of course, change the limbs into flippers, you have to change the tail into a tail fluke, which has a very different movement. You have to reorientate the whole birth process. If you would have a head-first birth, the young one would drown before it is completely born. You have to transform the whole nursing apparatus. You have to transform the kidneys for salt water. You have to transform the lungs, because whales, when they dive, they can inflate and deflate their lungs. But one of the most striking changes that is necessary is related to the body shape. And because whales, when they become fully marine, have to have a streamlined body, they internalize the testes that are otherwise external in mammals. And this has implications, because the testes, and we can look at a small video here, that's from one of the Illustra Media documentaries. And what you can see here is that the testes are now internalized at a position between large muscle packages that drive the tail fluke. And you may have heard muscles produce heat, and heat is bad for sperm count. So these whales had to come up with a system to cool the testes, and what they came up with is basically a refrigerator. They invented a counter-current heat exchange system to cool the testes, otherwise it would have been game over, because without viable sperm you're dead and don't have offspring. So this whole apparatus is extremely complex, is novel. It is not based on the so-called miraculous plexus that is present in other animals. This has been shown by developmental studies. So it is an innovation, and it required a lot of mutations. And even if you take very low estimates, you arrive at prohibitive waiting times. Now, this whole problem was already presented at a famous debate in 2009 at Beverly Hills, and there was Steve Meyer debating together with Rick Sternberg with two skeptics, with Donald Prothero and Michael Shermer. And Donald Prothero, he's a paleontologist, but it's obvious when you listen to this debate that he also didn't really understand the problem, but he was totally clueless and dumbfounded and couldn't respond to this thing. It's not like Darwinists could say, oh yeah, sure, it's no problem, we have a solution for this. And to give you a little idea why this window of time of 4.5 million years is really actually long, even though on human standards it appears to be is short, even though for us humans with our history of just some thousand years, it seems to be long, is if you look at standard textbook information, how long does a species exist? So not as individual of the species, but the whole species from its origin till its either extinction or dissolution. It's in larger mammals about 4 to 6 million years. By the way, based on a paper by Donald Prothero, who is a famous critic of intelligent design. So this window of time is just equaling the lifespan of a single larger mammal or vertebrate species. That is how short it is in terms of biological possibilities. If you imagine that you have to do this kind of re-engineering from a pig-like animal to a dolphin-like animal with all these changes in all these organ systems within the lifespan of a single species. And I recently found another problem that is related to this, and I formulated a challenge to Darwinists, which is yet not met, and that is the species pair challenge. And the question is, why should we expect that such a transition happening in 4.5 million years, and there are many examples like this in the fossil record, that this is reasonably explained with the Darwinian process if nothing like this exists in the present flora and fauna. And we can actually find out about this quite easily, and here is how. There is a database which you can find on the internet, and you can do this kind of playing with the data yourself. It's called timetree.org. And in this database, there are about 100,000 species, all groups of organisms from plants and protists to vertebrates and insects and so on. And they are combined with molecular clock data. And you can just select whatever pair of species you want. You can select 2 species and look how long ago did they separate in this alleged tree of life according to multiple molecular clock studies. And what I found is whatever you look for, there are no recent examples where you have this kind of morphological disparity, this difference in body plan resolved in a species pair that is dated to a similar time range that like Pachycetus and Dorodon. So we don't find any kind of this kind of transformation on the same time frame in living species. So just some examples to give you an idea. If you look at these two conifers, firs and cedars, they are separated according to molecular clock 141 million years ago, still look quite similar in terms of body plan. But this could be an outlier. Let's look at something else. Houseflies, common housefly, small housefly, for a layman, they look basically identical. They separated 48 million years ago, 10 times the time that was available for the whale transition. What about these two damselfly species? Identical for the layman, they, according to molecular clock, separated close to 12 million years ago. These two frogs, European common frog and moor frog, separated 21 million years ago. They again look identical. I didn't select these examples just as a kind of show to look for similar things. Try it yourself. Try to find anything that has a much lower span of separation and that looks more different. Apparently, that is what evolution can do in these time frames. If we look at other groups, not amphibians, but reptiles, here are two iguanas from the Galapagos Islands, also separated more than 18 million years ago and still look almost identical. In birds, it's a well-known phenomenon that if you have birds that are for laymen indistinguishable, they have a separation time usually far above 10 million years. So in this case, these are two warbler species. 50 million years they separated, and they can still hybridize. Here are the two sparrow species, which you have certainly seen yourself, house sparrow and tree sparrow. They separated more than 10 million years ago, still look identical basically. House mouse and rats separated 20 million years ago. If you neglect the size and you put images of the same size next to each other, many people will have difficulties to say which is which. If we look at a time frame that is more looking like the time frame that was available for the whale transition, you have something like this, the European bison and the cattle, and they still can hybridize and look very similar, no differences in body plan, no different organs. That is what we, in those cases in the fossil record, where we have these transitions in a window of time of 5 million years, we find different body plans. That means new tissues, new proteins, new organs. Nothing like this we find on the same time scale in the living fauna. Horse and ass, same thing, 7 million years separated, still can hybridize, still same body plan, very similar. Same with elephants, not only Indian and African elephant, but even if you compare the two African elephant species, they separated a longer time frame that was available to transform a pig into a dolphin. Same with bears, 60 million years, and these two species still can hybridize. And if we look at something where aquatic adaptation is involved, if we compare, for example, an otter, a river otter with this seal, they separated 40 million years ago, and they still look very similar, except for the fact that seals have transformed the limbs into flippers. And if this should have happened by Darwinian evolution, then you see what time frame is available, which, by the way, comes quite close to the initial estimate that Rick Sternberg calculated. Hippos, which are considered to be the sister group of whales, so they should have similar capabilities in terms of evolution. 10 million years between the pygmy hippo and the river hippo, still looking identical. What about whales? And if we look at whales and we look at the time frame that was available for this major transition, what we find in the recent fauna, dated based on molecular clock data, is the difference between a common dolphin and a bottlenose dolphin. That is what evolution can do in this time frame, unguided evolution. If it happened in this case, of course, but if we grant that evolution by natural selection is at least capable of producing, let's say, species diversity, different Darwinian finch species from our initial founder species, then this is the time frame where something like this can happen. What about ourselves? Now, if we look at apes and humans, the first interesting thing is that chimp gorilla diverged about 10 million years ago, and humans, as I said, about 6 to 7 million years from the chimp lineage. Now, there are two possibilities. You could either be one of those evolutionary biologists who say, hey, we are not so different from chimps. We just lack the hair and walk upright, but otherwise we are very much alike, and they will cite this DNA similarity. But I would say, no, chimps don't fly to the moon, chimps don't make soccer championships, chimps don't play chess, chimps don't write love poems, and so on. So there are, in our mental capabilities, major differences with chimps that are not reflected in this genetic difference. So if we would say, well, we are similar to chimps and gorillas and not so much difference in body plan, then it would be just another example for the case in point. But I would say this is an exception from the rule that I have showed before, and we are very different. And if it is only for our intellectual capabilities and moral capabilities from apes, then humans would be the only example I could find. And I really tried to find examples that disprove this thing. This would be strange. We humans would be the only example. This would resonate quite well with this kind of human exceptionalism that is postulated by the Judeo-Christian worldview. So that would be interesting, at least, and would not be easily explainable if we are just another mammal by Darwinian evolution. So I would say this whole thing, the waiting time problem where you can do the math and these related issues where you can really see what evolution can do in the available time frames are a kind of final nail in the coffin of Darwinism. And if you look at the facts and you look at the fossil record, we have an estimate that probably about 1% of all fossils have been preserved, because usually when an organism dies, it rots and it's not preserved as a fossil. So 1% of all species that ever existed are preserved in the fossil record, and we have about 350,000 described fossil species. Among these 350,000, which represent just 1% of everything that ever lived, we find a lot of examples for these fast transitions where in a short window of time you have these body-plan transitions. If you look at the internet, you can see other presentations that I give on these discontinuities in the history of life, from the Cambrian explosion to the origin of humans. Everywhere where you look, in all periods of Earth history, in all groups of organisms, if it is protists, plants, invertebrates, vertebrates, you find the same phenomenon, these sudden transitions, not gradual, slow transitions, but sudden saltational changes in body plan. We find this often in the fossil record, even though we have not so much fossil species, but among living species, where the estimate is that there are 8.7 million living species and 2 million have been described, and we find nothing like that. So what is the likelihood that we find in this larger sample no example, and in the much smaller sample a lot of examples for this kind of transition? This is a problem. So this is what I wanted to show you, and which hopefully makes you think. So thank you.
Grazie mille al professor Beckley per averci portato parole di sfida alla ipotesi più corrente, più accreditata per spiegare alcuni fenomeni che ci circondano e che si muovono nel campo scientifico. Perché alcune delle più diffuse? Perché sono quelle che normalmente troviamo nei libri di testo, che i nostri professori al liceo e anche io dopo ci raccontano, sentiamo nei documentari, leggiamo nei libri, però pongono qualche problema. Io apprezzo tantissimo la serietà, il rigore, prima ancora che scientifico, morale del professor Beckley nel dirci andiamo a vedere come sono le cose. Se una spiegazione, e tornerò su questo nella mia introduzione, nella mia conclusione, se un'ipotesi non spiega, bisogna provare, almeno provare, e avere questo legittimo dubbio, sacrosanto dubbio sulle cose, andare a provare un'ipotesi diversa, provare a formularla e vedere se tiene, la testiamo e vedere se tiene. Io credo che una delle cose più importanti che potrebbe fare questo nostro convegno oggi del CID insieme al Discovery Institute è mettervi un dubbio nella testa, che forse c'è un'ipotesi diversa rispetto a quella che ci raccontano e che però non tiene molto spesso. L'occhio, le balene, abbiamo visto gli scimpanzé, abbiamo visto i passeri, abbiamo visto tante specie. Almeno un dubbio sano su che cosa, un dubbio magari antico come la nascita della filosofia, ne parlava Sant'Agostino e quant'altro, anzi Agostino, parlo del filosofo. Ecco, se riuscissimo a fare questo con il nostro convegno saremmo, credo, soddisfattissimi.